Okay, normal distribution curve is
Now
there already. Okay, and we want to know whether the x is, what is the probability that x is in between a to b. Okay, say this is a and b. In this case we have to identify the area. So that area is nothing but, so if it is fx, okay, that area is nothing but the probability in between a to b. So we can write like this way, fx dx, so it represents the area in between these two. Okay, now if the curve is like that, if the distribution is like that, so it is called normal curve. It is called normal curve. Okay, now in the previous video we have solved that. So if a probability density function is 100 by x square, if x is equal to 100, 0 elsewhere. So already you have solved this particular problem. So this is nothing but a probability density function of a figure, like figure will be like that. So from 100 it will be like this one. Okay, now the question is, what is the probability density function for the normal curve? Now the probability density function for the normal curve is 1 by sigma square root of 2 pi e to the power minus 1 by 2 x minus pi by sigma square. Okay, so this is nothing but a probability density function for a normal curve. Okay, where this x varies from minus infinity to plus infinity, mu varies from minus infinity to plus infinity, and sigma should be greater than 0. Okay, now a random variable x is said to have a normal distribution with parameter mu and sigma square. Okay, so here two parameters are there. So x is a normal variable and two parameters are mu and sigma square. These two are the parameters. Okay, now standard variable. So what is a standard variable? Now already you know, suppose we have one data, say 1, 2, 3 and 6. Okay, now we can convert this into standard variable. So the formula of the standard variable is z x minus mu by sigma. Okay, now so what is mu? Mu is a mean of this particular data, and what is standard deviation? Standard deviation of this particular data. Now mu, okay, so if you calculate the mean, so mean of this particular data is equal to 3. So 1 plus 2 plus 3 plus 6 divided by 4, 3, and standard deviation is 3.7416. Okay, now to calculate, to know the z value, associated z value, so if for this particular data, so 1 minus, say assume it is z1, 1 minus mean by standard deviation 3.7416. Okay, and the value is minus 0.5345. Okay, so minus 0.5345, and for z2, 2 minus 3 by 3.7416. Okay, so the value is minus 0.2672 or 3. So 0.2673. So 3 minus 3, here it is 0, and Z4, so 6 minus 3 by standard deviation, the value is 0.8018. Okay, now this is nothing but a standard variable. Now if you calculate the Z bar, okay, if you calculate the Z bar, mean of this, the output will be 0, and if you calculate standard deviation of this particular variable, the output will be 1. Okay, so this is a x, this is, so we have to calculate mean and standard deviation, and from mean and standard deviation we can get the Z values, and if you calculate the mean of this particular data, the output will be 0. If you calculate the standard deviation of this particular data, output will be 1. Now, so the variable x is there, though probability density function for the normal curve will be like this. Now if the variable is z, okay, so if the variable is x, the probability density function is e to the power minus 1 by 2 x minus mu by sigma square. Now if it is z normal form, standard normal form, then the probability density function is square root of 2 pi, because here sigma is 1, okay, sigma is 1, e to the power minus 1 by 2 z square. The curve is bell shaped and symmetrical about the line. The curve is bell shaped. The curve is bell shaped. Okay, like Giza's bell. Now the curve is bell shaped and symmetrical about the line mu. Okay, so x equal to mu. It's a symmetrical, means 50% this one, this part is the 50%, the remaining is the 50%. Okay, so it is symmetrical. This is similar to this particular part. Okay, next. Mean, median and mode of the distribution coincide. So this is nothing but our mean, this is nothing but our median, this is nothing but our mode. Clear? Next, beta 1 is 0, beta 1 is 0, and beta 2 is equal to 3. So beta 1 is 0, beta 1 0 is means it is symmetric. So already you know, if beta 1 is positive, it is positively skewed. If it is negative, then negatively skewed. If it is 0, then it is normal form. So it is a normal curve. Beta 2 is equal to 3. Beta 2 is equal to 3 means it is mesokurtic. So already you know, in the previous videos we have seen that in kurtosis video part, if beta 2 is equal to less than 3, it is platokurtic. If it is more than 3, it is leptokurtic, and if it is beta 2 is equal to 3, then it is mesokurtic. So this is nothing but our mesokurtic. Okay, and beta 1 is equal to 0, so that means what? So no skewness is there. Okay, it is a normal. Next, no portion of the curve lies below the x-axis or touches the x-axis. No portion of the curve below the, actually it, so it is like that, minus infinite to plus infinite, it will not touch, okay, or it will not cross this x-axis. So the meaning of that. Next, linear combination of independent normal variates is also a normal variate. So the meaning of that, suppose x1 is like this one, okay, and x2 is like this one. So if it is for x1, if it is for x2, if you add x1 plus x2, the output will be also a normal curve. Okay, so the meaning of that. Next, quartiles. So q1 is equal to mu minus 0.6745 sigma, and q3 mu plus 0.6745 sigma. Okay, so quartile So already you know this one. So this is nothing but our Q2, the median. So Q1 will be somewhere here, and Q3 will be somewhere here. So Q1 value is this one, and Q3 value is this one. Okay. Next, the most important is the area property. Area property of the normal curve. Okay. Now, okay. Now area property. Suppose there is one curve. This is a normal curve. So already we know. So minus infinity to plus infinity, total area is 1. Okay, total area is 1. Now, so it is a mu. So minus infinity to plus infinity. So minus infinity mu minus sigma to mu plus sigma. This particular area, total area is equal to 0.6826. Okay, this particular area is 0.26286826. Now similarly, mu minus 2 sigma, mu plus 2 sigma, total area from this portion to this portion, the total area, the value is 0.9544. So this total area is 0.9544. Similarly, mu plus minus 3 sigma from mu plus 3 sigma, the total area is 0.9973. Okay. Now if it is a normal curve, if it is a standard, if you are using standard variable, so we can use this one like this way. So mean is equal to 0. Okay, so it's a normal form. So already you know, if it's a normal standard variable, so the mean is equal to 0 and standard deviation is 1. So middle 50%. Okay, so middle 50% means we have to add 0 mean plus 0.745. So 0.745 plus minus 0.745, the total area is 50%, or probability in between minus 0.745 to plus 0.745 is 0.50. Similarly, it is if it is from 1 to 1, say 1 plus 1 to minus 1. So in between plus 1 to minus 1, it is the area, the probability is 6826. Okay. Now suppose you want middle 95%. So middle 95%, so it is plus 1.96 to minus 1.96. So middle 95% is this particular portion. Okay. Similarly, so it is a mean 0. So minus 2 to plus 2. Okay. So minus 2 to plus 2, that means this particular area. So plus 2 is nothing but 0.9544. Okay. Similarly, plus 2.58 to minus 2.58. Suppose you want middle 99%. Okay, so this particular area. So 0 plus 2.58, 0 minus 2.58. So total area is 99%. Okay, or 0.99. Okay. Similarly, 0, so plus 3 to minus 3. So total area, this plus 3 to minus 3, it is 0.9973. Okay. Okay. solve one problem. Suppose mean is equal to 20 and standard deviation is 10. So then calculate probability of x more than 30. First problem. Second problem, probability of x less than equal to 10. Third problem, probability of x in between 10 to 30. Next, probability of it is 10 to 20, and finally 25 to 28. Okay, now how to solve this one? So we have to solve this one, we have to see how to refer the Z table. Okay, you can see this particular table, it's a Z table. Okay, it's a Z table. Now to solve this one, we can use this one. So first of all, convert this. Suppose in this particular problem, say mean is equal to 20, we want to identify the area which is more than 30. So 30 will be somewhere here, it is greater than value is there, that means area should be this particular part. So we have to identify this particular area. Now to solve, we have only the Z table. Okay, we have only the Z table. So we have to convert this x to z. So already you know how to convert this one. So x is equal to z is equal to x minus mean by the standard deviation. Clear? So x minus mean, so 30 minus 20. So this is nothing but a 1. So 30 minus 20, 10, 10 by 10, it is 1. So if it is a normal curve, okay, so if it is a normal curve, then 0. Okay, standard variable is if it's a normal curve for the standard variable, then it is 1. Okay, so we have to identify this particular area. Now you can see this particular figure, it is starting from 0 to positive portion. Okay, and you just remember this one, it is symmetric, means 0 to z and 0 to minus z, the value should be the same. Okay, now it is plus 1. 1 means we have to see this one. So z 1, okay, 1, and associated is 1.00. Okay, so 1.00 means 1.00 means 0.3413. Okay, so 0 to 1 it is 0.3413. Okay, now it is symmetric, means left side 0.5, right side 0.5. Okay, left side 0.5, right side 0.5. So if the total right portion is the 0.5, okay, and this particular portion is 0.3413, so easily we can get this particular area. So total area is 0.5, subtract this particular part is nothing but this particular area. So this total right side part is 0.5, from this to this it is 0.3413, and then this particular portion is 0.1587. Okay, so probability of x more than 30 means what? Probability of z more than 1. Okay, so we have converted this x to z, and the answer is 0.1587. Similarly, probability of x less than 10. So less than 10 means, so less than 10, so mean is what? Mean is 20. Less than 10, this is 10. Less than 10 means what? This particular area. So you have to convert this into z form. So z is equal to minus 10 minus 20 by 10. So it is minus 1. Okay, so that means it is like that, 0 minus 1 less than 10. Okay, so x less than 10 means probability of z less than equal to 1, minus 1. So less than -1 means what? This particular area. Since it is less than, so less than part is what? Minus, so left part is the less than. Now you can see this particular table, it is only from, the values are only from 0 to z. Now suppose you want to identify 0 to -1. So how to know this one? So already you know 1.00 is 0.3413. So 0 to 1 is 0.3413, and since it is symmetric, so 0 to -1 also 0.3413. Okay, so from table we can get 0 to 1 is 0.3413, and since normal curve is symmetric, so 0 to -1 also 0.3413. Left portion is 0.5, from 0 to -1 is 0.3413, so this particular part is so same as 1587. Okay, now next solve another problem. Probability in between 10 to 30. So 10 to 30, that means it is 20, 10 means this one, 30 means this one, so we have to identify this particular area. Okay, so in terms of z, if x is equal to 30, z is equal to what? 30 minus, so it is +1. If x is equal to 10, z is equal to -1. That means it is +1 to -1. That means this particular area. And already you know that from 0 to 1 it is 0.3413, and from similarly, since it is symmetric, 0 to -1 is also 0.3413. So the total area is 0.3413 plus 0.3413. So 0 to +1 0.3413, 0 to -1 0.3413. So we have to add these two values. So if you add 3413, the answer is 0.6826. Okay. Okay, so probability of 0 to 30 means probability -1 to +1. The answer is 0.6826. Next, 10 to 20. 10 to 20 means it is like that. So mean is 20, 10 means this one, so we have to identify this particular area. So we have to convert this into z. So -1 to 0. So if x is equal to 20, z will be 0. If x is equal to 10, z will be -1. So in figure 0 to -1, so we have to identify this particular area. Okay, so already you know 0 to 1 is 0.3413, so 0 to -1 is also 0.3413. So p in between 0 to -1 is 0.3413. That means probability of x in between 10 to 20 is 0.3413. Next, the last problem. What is the probability in between? So 25 to 28. 25 to 28. So we have to identify this particular area. Okay, mean is equal to 20. 25 to 28. Now we have to convert this into z. So if x is equal to 25, z is equal to what? 25 minus 20 by standard deviation 10. Okay, so it is 0.5. Similarly, if x is equal to 28, z is equal to 28 minus 20 by 10, so it is 0.8. From the table we can see here, if it is so, okay, now it is 8.5.8. So 0 to 0.8. Okay, so you can see here 0.8. So 0.8, 0 0, it is 0.28881. Okay, so 0.2881. now 0.5 0 0, it is 0.1915. so 0.5 0.1995 1915, sorry. If it is 0.5, you can see here once again 1915 1915. So 0 to 0.8 it is 0.2881, and 0 to 0.5 is 0.1915. so how to know this one? So this minus this is nothing but this particular area. Okay, so the answer is 0.0966. Clear? So probability in between 25 to 28, that means probability in between 0.5 to 0.8 is equal to 0.0966. Okay, next. So is it clear? So how to use this Z table? Suppose Z value is 1.63. Okay, so how to know this particular value? So 1.6 1.6 and 3 means what? 0.03. so that means we have to, the value should be 0.4484, 1.63. Clear? Now suppose the Z value is 0.77. so how to know the probability? 0 to 0.77. so 0.7 is this one. Okay, 0.7 is this one, and we have to move 0.7 to, so it is 0.07. Okay, so 0.77 means what? 0.7 here and 0.7 here, so answer is 0.2486. Okay, so 0.7 here and so 0.2794 is the answer. If the value is 0.43, so 0.43 means what? This one 0.1664. Similarly, 2.48, so 2.4 this one, and 8 means up to this one, so this is nothing but for 8. Okay, so you can see here this is 8. Okay, so we can get the values like this way. Next, X is normally distributed with mean 12 and standard deviation is 4. So find the probability that X is more than 20. First question. Second question, it is less than 20. Clear? Third question, probabilities in between 0 to 12. Okay, and finally fourth one is very typical one. Find X dash when X is more than X dash is equal to 0.24. Find X dash when random variable is more than X dash is 0.24. Probability of X more than X dash is 0.24. So how to solve this? We have to convert this into Z. So already you know this one. So first question, probability of X more than 20. So we have to convert this into Z. So mean is 12, 20 is this one. So we have to identify this particular area. Now Z value is 20 minus 12 by 4. Okay, because 12 is the mean, 4 is the standard deviation. The answer is 2. So if it is probability of Z more than 2, clear? So 0, 2, so we have to identify this particular area. Now what is the probability for that? So if it is a, so already you know the table. So 2 means this one 2.00.4772. So so 0 to 2 it is equal 0.4772. we know that right part is the 0.5, so this particular part is 0.5 minus 0.4772. Are you getting this one? This particular part is 0.5. From 0 to 2 is 0.4772. So how to get this one? So 0.5 minus 0.4772, answer is 0.0228. Okay, next. Second problem, probability of x less than 20. Okay, mean is 12, less than 20, so 20 is where, so less than 20 means the whole part. Okay, so if x is equal to 20, z is equal to what? 2. Just we have solved. If x is equal to 2, so in if it is a standard normal variable, it is 0. Okay, it is 2. So this particular part. Okay, 0 to 2. Now already you know 0 to 2 it is 0.4772. Okay, now the left part is 0.5. So this particular part is 0.5. It is 0 to 2 is 0.4772. The total area is, so total area is 0.5 plus 0.4772. So probability of x less than 20, probability of z less than 2. Okay, so 2 means what? Minus infinity to 2. Okay, so the answer is 0.9772. Okay, next, third, what is the probability in between 0 to 12? Okay, so 0 to 12 means 0 to 12. So if x is equal to 0, z is equal to, so 0 minus 12 by 4, it is minus 3. If x is equal to 12, z is equal to 12 minus 12 by 4, it is 0. Okay, so we have to know, we want to know the area in between 0 to 12. 0 to 12 means what? So somewhere like this particular area. Okay, so if it is standard variable, so 0, it is minus 3 to 0, minus 3 to 0. We have to identify this particular area. So how to know this particular area? Already you know how to know this one. So 3.00 3.0 is 0.4987. Okay, so 0 to 3 is 0.4987. Since it is symmetric, so 0 to minus 3 is also 0.4987. So that is the area. So probability of x in between 0 to 12 is equal to probability of z minus 3 to 0. The answer is 0.4987. Okay, now finally find x dash when x dash probability of x more than x dash equal to 0.24. Okay, so for this particular problem, now right now till now we have done this from z value probability. Now in this particular problem, we have to identify the z value from the probability. Okay, so now say it is mean. Okay, what is given? X dash, suppose it is x dash, probability of x more than x dash is equal to 0.24. Okay, so more than is there, that means what? This particular area, so it is 0.24. now we have to identify the x value. We have to identify this particular, this is given, it is given. So but the table, you can see the table values are from 0 to z, not from z to infinite. So that's why we have to identify this particular area. So how to identify this particular area? So already you know from this point to positive infinite it is 0.5. So it is nothing but 0.5 minus 0.24, so 2.6. So therefore 0.5 minus 24 is equal to 0.26. Okay, so this particular area is equal to 0.26. We have to identify the table entry which particular data is very near to the 0.6. So you can see here 0.2611. Okay, 0.2611 is very near to the 0.26. So 0.2611 z value is 0.7, and here it is 1. So z, if probability or area is 0.2611, why 0.2611 near to the 0.26? You can see the other values. 2580 is the difference is 20. Here the difference is 11. Okay, therefore we have to use the nearest value, nearest z value. Nearest z value is what? 0.71, not 0.70. So if you select 0.70, then it is 0.2580. So difference between 0.2580 to 0.26 is 0.0020, and here it is 0.0011. So this one is the nearest one. Therefore z is equal to 0.71. Okay, so p is equal to 0.26, z means 0.71. Okay, so x dash is nothing but 0.71 in z. How to convert this x dash to z? So x dash, z is equal to x dash minus mean. Mean is 12 by the standard deviation is 0.71. Okay, so x dash is equal to 0.71 into 4 plus 12. Answer is 14.84. Okay, solve another problem. The mean yield for 1 acre plot is 662 kilos with a standard deviation 32 kilos. Assuming normal distribution, how many 1 acre plots in a batch of 1000 plots would you expect to have yield? Number 1 over 700 kilos, and number 2 below 650 kilos. What are given? Mu is equal to 662 and standard deviation is 32. Okay, probability over 700 kilos, mean 662, 700 kilo means we have to identify this particular area. We have to identify the z value. So z value is 700 minus 662 by 32. It is 1.19. Okay, if it is z 0 to 1.19, we have to identify this particular area. Now 0 to 1.19, you can see the table. 1.19, 0.3830. Okay, 0 to 1.1 is 0.3830. Total right part is 0.5. 1, so 1.19, so 0.5 minus 3830 is 0.5 minus 3830 is 0.1170. Hence, in a batch of 1000 plots, the expected number of plots with yield over 700 kilos is 1000 into 0.117. Answer is 117. Okay. Second is below 650 kilos. Below 650 kilos means probability of x less than 650. we can draw the figure. It is 662, it is 650, means we have to identify this particular area. Z value is 650 minus 662, sorry 650, okay, 650. Standard deviation is 32, okay, it is minus 0.38. So if it is 0.38, the answer is, if it is 0.38, 0.3, then 8, 0.1480, okay, 0.1480. Okay, so 0 to 0.38 is 0 minus 0.38. We have to identify this particular part. So 0 to 0.38 is 0.1480. So 0 to 0.38 is 0.1480, and since it is symmetric, so 0 to 0.38 is once again 0.1480. Leftmost part is 0.5, so total is 0.5. We have to subtract 0 to this, so 0.1480, and answer is 0.352. Okay, therefore the required number of plots with yield below 650 kilos is 1000 into 0.352. 352 is the answer. Okay, and that is the end of this particular video.